you're going to be substituting the variables, okay? So, again, substitution and evaluation, and they both go together. They're very related. So substitution simply means to replace the variable. When I say variable, what do I mean?
You mean the letter.
The letters, right? That stand for some unknown number. Replace the variable with a given value. Now let's talk about what that means. A value is usually just a number, some constant, some number that you have. And if I say given, does that mean you just get to choose whichever one you want? No, it's that you have to replace it with the number that they tell you to use. Yeah? And there's only one place that causes problems here for students. And I'm going to show you what that is. Never replace a variable. No, you actually can. Okay? Without using a bracket. Okay? So never replace a variable without using a bracket. And I'll tell you why. Remember when we did the algebra conventions? We don't usually write the multiplication symbol. If I wanted to say 2 times x, I would just write it as 2 and x side by side like that. Remember, that literally means 2 times x. Okay? Well, if I told you that I wanted you to substitute 6 for that, look up here, guys. All right? So, could I just put the 6 in place of the x and be done? No, because that's 26, which is not the same thing, right? So in order to keep the operation true, what we have to do is use a bracket. So what I'd do is I would write down the 2, and then in place of the x, put the 6. And remember when we talked about our algebra conventions, we talked about a number in front of a bracket. That always means what operation? Times or multiply, right? When you have it, if the number is right next to something. In other words, if you don't see a symbol, right? This one does not mean multiplication because I have the addition symbol, right? But this one doesn't have any symbol between the number and the bracket, so that means always multiplication. Yeah? So what is 2 times 6 going to give me? 12. So we just substituted and evaluated. Okay? Right? So never put a number in place without a bracket. Now, in Education Perfect, when they start off, they don't put the bracket, which I don't like. But then later in the same lesson, they start putting the brackets in. But for you guys, when will you use a bracket? All the time, right? And it's really important that you get into good habits now, because later, as your algebra gets more complex, right? If you know how to do it, if you're good at putting things together properly now, then you'll be good at it then, right? No matter how big or how small the problems are. Okay, so that's substitution. It just means replace the variable with the letter with the number they give you. Okay. Now. Okay. So we've talked about substitution, right? The other thing we need to talk about is evaluation. And I actually just gave you a clue there. When you see the word evaluation, what do you think is the root of that word? Evaluate. Well, or evaluate, or just value, really, right? Value is the root of the word, or evaluate. So a value, okay, just means usually a number in mathematics when we're talking about a value. So evaluation means to plug in the number and do the math. And there's a word for that in mathematics. Remember that anytime you see the word simplify, that is the math word that means just do the math. So is there any addition, right? Subtraction, multiplication, division, but you follow the order of Operations. There you go. Yeah, you guys are killing it here. All right. So following the order of operations. So simplify, anytime you see that word simplify, it means do the math. Follow the order of operations and make it as simple as you can. Okay? So do the math. But make sure that you're following the order of operations as you do it. Right? So this last one we did, when I did the 2 times 6 to get the 12, that's evaluating. Right? Substituting was just plugging the 6 in, right? Evaluating means I did the problem. That's all there is to it. Now, so what we're going to do is we're going to go on to Education Perfect and look at some of their examples so that you can see some of the processes in different ways. Because many times these are given to you in sentence form. Okay? And we're going to look at some of those. So you've been using the same idea of building an expression that you could use for all kinds of problems. We had, for example, area equals 1/2 times base times height. What is that the formula for? The area of a triangle, right? And all you did was find those measurements, plug those numbers into the right spot, and then do the math. That's substitute and evaluate. So do you see that this is nothing new? The format of it might be a little different because what you're going to do is you're going to have to think about what variable to use, what letter to use. But remember, that's easy too. What if I'm talking about some number of hours? What do you think I should use as the letter? H, right? If you're talking about some number of sheep, S. They like to use farm animals for some reason. You're going to see lots of them. Cows? C. Okay? So, okay, she's got German cows. All right. So, let's look at some examples of just substituting and evaluating. So, what if we wanted to know how far we could drive with 10 liters of petrol? Okay? 10 liters of petrol. So New Zealand. All right. So we're using L to describe the number of liters we have. So, well, I don't know. So we can replace the L in our expression with 10, right? Because we want to know about 10 liters. So here's our expression. 14 times L, which means that for every 1 liter, we can go 14 kilometers. Okay? So if that's true, then all we need to do is replace the L with what number in this case? 10, because they gave it to us, right? And then just do 14 times 10, which gives us what? 140. But look at closer. 140 what? Remember, when we replaced those things before, we always had to use our units. So make sure that if it has units, your answer has units in it. Okay? All right, so all we did was replace with a given value. So I want you to do one. Everybody ready? I want you to do the same thing, but I want to see how far you could go on 6 liters of petrol. Okay. Already? You've got them? Pardon? Oh, be careful. Look at your formula. So we get 14, right? But this is 6 liters, so where am I going to put that 6? In place of the L. So it's 14 times 6. Who's got an answer for that one?
84
So 84 kilometers. Okay? So make sure you're putting it in the right spot. So all you needed to do is put 6 in place of the L because it was 6 liters. Okay? All right? Okay. So all you're doing is replacing the letter with the number that they give you. You can also have lots more of much more complicated algebraic expression. Why do I call it algebraic? What is it called? Algebra. It's got exactly, because it has letters in it. Anything with letters in it is algebraic, right? So it's just called algebraic because of the letters. So you see that they gave you, in this particular example, they gave you 3 plus q. They replaced the q with a 5. And then all that's left to do is evaluate it or calculate it, do the math. So in this particular instance, if you did 3 plus 5, what would you get in the top? 8. Good.
8 by 4.
And then you still have divided by 4, which is going to give you 2. There you go. All right. Right? So evaluating just means plugging in the numbers. Now, one thing I don't like, though, is they didn't use a bracket. But in this case, the 3 plus 5, the reason they didn't is because 3 plus 5 is a really simple expression. And since it didn't mean multiply, they didn't worry about it. But I would rather you use them, because it's never going to be wrong to use too many, but it is wrong if you use too few. Okay? And we'll look at some examples to show you that. So here, they have another example, 8p plus 4. Right? And here's why they're doing the substituting. So if you have 8p plus 4, and I say p is equal to 5, that means that anywhere there's a p, I'm going to replace it with what number? 5. But I can't just do this, can I? Is that what that means? No. I have to put it in a bracket to indicate that the multiplication, right? And then that means 8 times 5, which is 40, plus the 4 gives me a completed answer of 44. Does it make sense? Pretty easy, yeah? So all we're doing is evaluating algebraic expressions with numbers they give you. So you don't have to think about where they come. So look at this one. We can take 4 passengers per trip. Anytime you see that word per, there are some words that always mean the same thing. We might have talked about of, but I don't remember. Of, if you ever see the word of, it always means to multiply. I can't write, but there it is. Okay? And the word per generally indicates divide. Think about it. Kilometers per liter. That's going to mean over liters. So here we have number of trips is the number of sheep you can take per trip is 4. So we get S, number of sheep, divided by 4 will tell us how many trips we need to take. Right? So look at, so what if we had, how many trips would that mean for 20 sheep? Go.
Sheep.
So you have 20 sheep.
5.
Okay, a little premium, but yes, right? So that just simply means 20 divided by 4, which means you'll have 5 trips. Excellent. Okay. Eager. All right. So that goes into your exercises. We'll go on to the next one. So now they talk about evaluating, but remember, after you substitute, we've already been evaluating, haven't we? Because I didn't just let you put the number in place without doing the math. So that's all it means is to do the math, right? Okay. So here they're talking about speed, so they're letting speed represent the change. Okay. So look at this example. We have someone paddling a boat, and they can paddle at 7 knots, but the sails will also catch the wind, right? So that should make the boat go even faster than that. Do you agree? And it says that it's 3 times the wind speed will tell you how many knots you can go by the wind. So, sorry, I went too fast for you. There we go. No, I didn't. It's where they give it. So, the current base, so the wind speed and the gain by paddling are given there. So, if the wind goes 3 times, that is 3 times the number of knots. So that's where we get.
22.
So, depending, okay. So all we need to do, so if we know the wind is 5 knots, right? Then you're simply going to replace it with 5 and then do the math. So let's do that. So 3 times 5.
50.
Yeah, plus our 7. So that gives us 15 plus 7, which is
22.
22. And 22, what kind of units? knots. Okay? So you have the rowing takes you a constant speed. Remember that a number like this is called a constant? And that's one of the reasons why. He was rowing, so he's going to do a constant speed, but the wind blows at different speeds all the time, doesn't it? If any Wellingtonian doesn't know that, then you haven't been outside ever. So you get this, the variable part of it is the wind speed, because we don't know what the wind speed is going to be. It's never going to be a constant, right? Okay? All right. So they work out the problem there for you. Okay, then it goes into your homework, so you're going to have some more of those to do. Whoops. Let's see what else they do to you. Let's look at what happens when you have a problem that has more than one variable. Okay? So remember that each variable represents one item. So if I say that W equals the wind speed, could I use W to equal anything else in that same problem? No. Okay? But what if I also had paddling? Could I have a problem where I had paddling and wind in the same problem?
Yes.
You bet. But could I use the same letter for both of them? No, because they're different unknown quantities. We have to use different things for them. So they're talking about those tiles from some famous game that we won't name because it's probably against the rules. You have grassland tiles, forest tiles, and mountain tiles. So that's how many different types of tiles?
3.
So how many different variables will I need? 3. Get it? So they have G for grassland tiles, they have F for forest tiles, and M for mountain tiles, right? And you have to give points for each one of them. And so it's 2 for every forest and 3 for every mountain. Yeah? So that's where we get the formula for the action points. So that's why they have the 2 in front of the F and the 3 in front of the M. So if I wanted to evaluate that for those particular values, all I would do is in place of the G, how many grassland tiles do I want? 3. In place of the F, I would put 1. And in place of the M, I would put 2. And so you see that they did that there and worked it out to get how many action points you would need total. So you can have more than one variable in a problem. That just means you need to put the right number in the right spot. Be careful. Do you think they'll always give them to you in order? No. So be very careful when you're reading these to make sure you get the right number in the right spot. Now, they'll give you the formula, the thing to plug it into, but you have to make sure you're getting them in the right spot. Okay? So you can't have more than one variable. Okay? So how many action points would it take to walk this route? So what we're going to do, remember that you have to know which tiles they are, right? So let's write down the formula again. It was G plus what? 2F plus 3M. Right? So first, let's see how many of each tiles we're going across. Okay?
We're going across 1 grassland tile and 2 forest tiles.
So 1 grassland, right? And 2 forest ones?
So we eat
Okay. How many mountain ones?
0.
Right? But what about, do I have to include the ones at the end?
I don't know.
If I'm crossing those? I don't know about the start. So let's see if we include those start ones and find out. But what I want you to see here is that I have to put something in place of G, right? I have to put something in place of F, and I have to put something in place of M. But how many mountain tiles did we use? 0 of them, right? Because every single value has to be accounted for. We can't leave any of them off, right? So let's see if they counted those original ones. So 2 grassland, 2 forest, and 0 mountain tiles. So they didn't count the beginning and end, oddly enough. Okay, so you'll see how they put those in. Oh, yep, sorry. Okay, and so when you do the math, look what happens to those mountain tiles. Since I had 0 of them, what's 3 times 0 going to make? 0. So from the first one I get 2. 2 times 2 gives me 4 forest tiles, but then I have 0 mountain tiles, so they don't even put in adding in the 0 because adding 0 means it doesn't change anything. Yes?
How did you get the 3 in front of the
Remember that each one of them cost a certain number of action points.
Oh, okay.
So every one mountain costs 3 points.
Oh, okay.
So that's where the original formula they have. And then 2 for the forest tiles. Okay? So be careful. If you don't have any, then make sure you put in a what? Well, if you don't have any, put in the value. What value? 0. 0 is the number for none, right? Good job. Okay. Then they're going to give you some where you have combinations. But again, all I'm going to do is plug in the right number in the right spot and then do the math according to the order of operations. Yeah? Okay. So they replaced S with 12 plus, but they need a C, right? And it says that there are 5 cows, so they replaced that with 5. We have to do the division first, so they did the 12 divided by 4 first. Got 3 plus 5, which gives you 8 total trips. So be careful about putting the right thing in the right spot, and also be careful to make sure you're using the order of operations. What would happen if I added that 12 and that 5 together first? You're going to get a mess, right? So you'd end up with 17 divided by 4, which is a mess. It's not right either, right? So be careful about the order of operations.
12 plus 5 over 4.
Exactly. If they wanted to say that, they would have to put the entire thing, of course. Okay? All right.